Hello, everyone. My name is Victor, and today I'm going to talk about supervised versus unsupervised learning. The agenda for today, I'll go through the big picture first, then I'll talk about supervised learning, regression and classification problems in that category, and then at the end is unsupervised learning with some examples. So first of all, the big picture, classical machine learning. There you can think of it of two big groups of problems that we can encounter. Supervised learning is one, unsupervised learning is the other one. Under supervised learning to the left of the screen, when I highlight it, we find classification problems, which I'll dive deeper in a bit, and regression problems. Under unsupervised learning, we're gonna focus more on data. So we're gonna cluster data, make associations, try to understand the data. So let's dive deeper into it. So for supervised learning, so the main point for supervised learning is that we have labeled data. And what labeled data means is, let's say we have images, and then these images are for dogs, this other set of images are for cats, and this other set of images are for chickens. So then you can train a machine learning model through supervised learning. Once you have that model, then you can make predictions. So let's say given a new image that you don't know if it has cats, dogs, or chickens, you want to predict that. So now you can actually predict that using the model that you trained previously. So the main point with supervised learning, we have labeled data. We have data and its corresponding labels, and then we can train from that data to predict later in the future. Some two big categories under supervised learning are regression and classification. The main difference is the variable that we are predicting. So if it's a continuous quantity, then it's a regression problem. Let's say the temperature. Temperature could be 84 Fahrenheit or any number, right? So it could be even like decimal numbers like 84.5 or so and so on. So if you are predicting a number, a continuous variable, then that's a regression problem. On the other hand, for classification, as its name indicates, you are predicting classes. So you have a class, let's say cold, and then you have another class, let's say hot. So now in this case, instead of predicting a number, you're predicting a category, either it's cold or hot. So one of the two. That's the main difference. So that's what regression and classification is. Uh, Outside supervised learning, so we have unsupervised learning as we were looking at the diagram at the beginning. And in this case, we don't have labeled data. We have just data, and then we want to find patterns in the data. We want to associate it, see if there are clusters and so on. Like we would like to answer a couple of questions about the data. Let's say some questions could be like, are some observations clustered into groups? Or are there interesting relationships between the features, or which ones are more relevant, and so on. So for this type of questions, we use unsupervised learning. Let's say in this example, let's say we have data about customers, and each point represents a customer information in a space. So let's say now we want to find clusters, because maybe we could run a marketing campaign and target each cluster independently. That could be one application of it. So let's say in this case, we train a supervised learning algorithm to find those clusters, to see which ones are close together. Later in another video, I'll talk about like what type of algorithms we can use for unsupervised as well as for supervised learning. For now, I just wanted to clarify what unsupervised versus supervised learning is. And then if you have any questions, feel free to email me. This is my email. Thank you.